Hey, welcome. You know when you're staring at an exam question and thinking, what exactly do they want from me? Well, today, we're going to pull back the curtain. We're not just answering a GCSE Physics question, we're taking it apart piece by piece using the official mark scheme. This is your insider's guide to getting every single mark. Okay, so here's our challenge for today. This is question 4 from a real AQA exam paper. Looks kind of weird, right? All those different tubes, but it's actually designed to test a really basic, fundamental idea about pressure. So let's crack this thing open together, step by step, and see what it really takes to get full credit. Okay, let's get right into it. We're starting with the first part of the question, and this one is all about what you can see and what you can draw. The question asks you to complete the diagram. It's for 1 mark, so take a look. How would you draw the water levels in the other 3 tubes? What do you think the physics is telling you to do here? And there you have it. To nail that mark, you just draw a straight line right across. The water level is exactly the same in all 4 tubes. The key thing to remember is that pressure in the liquid doesn't care about the shape of the container. Not at all. It only depends on the depth. Since the pressure at the bottom is the same everywhere, the water height has to be the same too. And get this, here's the exact wording from the mark scheme. All heights drawn the same as tube 1. That's it. It's that simple. No complex explanation needed. The examiner is just looking to see if you drew a straight line. 1 simple action, 1 easy mark in the bag. That's our first big clue.
Okay, part 2. We've gone from drawing to explaining. Now you have to put the physics into actual words, and you can see the stakes are a bit higher. This one is worth 2 marks.
So the question is, explain why pressure increases the deeper you go. Now, the absolute key here is that little bit that says it's worth 2 marks. That is a massive clue. It means the examiner is looking for 2 distinct connected points. A single fuzzy statement just isn't going to cut it.
And this slide right here, this is basically the blueprint for a perfect answer. These are the exact phrases the mark scheme is waiting to see. For the first mark, you say that going deeper increases the height or mass or volume of the water right above you. For the second mark, you have to link that to an increase in the weight or the force of that water. It's a simple cause and effect.
Now this is so crucial. Precision matters. The mark scheme is very clear that just saying there's more water above isn't good enough. An examiner wants to see that you get the physics. Are you talking about the height of the column, the mass of the water? It's the weight of all that water creating a force, and that's the key to getting that second mark. Using those specific scientific terms is absolutely essential.
All right, let's move on to the final part, a 3-mark calculation. This is where showing your work in a really clear, methodical way is your absolute best friend. It can even save you if you make a tiny mistake at the end.
Before we even think about plugging in numbers, let's remember our tool for the job. This is the equation you need for pressure change in a liquid. And the best part? It's right there on your physics equation sheet. You don't have to memorize it, but you definitely need to know how and when to use it.
Now we can see exactly how those 3 marks are given out. The first mark is for correctly substituting the numbers from the question into the formula. Easy enough. The second mark is for punching that into your calculator and getting the right answer. And the final mark, the one so many people forget, is for writing down the correct units, in this case, pascals or pa.
Now for some serious insider tips, straight from the examiner's notes. Technically, if you just write the correct final answer, you get all 3 marks. But that is a huge gamble. 1 tiny typo on your calculator and you get 0. So please, always show you're working. And check out how specific they are about the units. Pascals, PA with a capital P, or N/m² are all good. But pa with a lowercase p? Nope, you lose the mark. It's that strict.
So let's pull all of this together. We've just gone through an entire question and basically created a blueprint for how to get full marks on almost any question like this.
So this is the game plan. You've got to understand the command word. Are you drawing, explaining, or calculating? You have to decode the marks. A 2-mark question needs 2 clear points. You need to be precise with your language and be methodical with your math. But the most important thing is to practice with past papers and their mark schemes, just like we did. It trains your brain to think just like an examiner. So there you have it. The mark scheme isn't some kind of secret document. It's an instruction manual. You can stop guessing what examiners want and start using the mark scheme to give them exactly what they're looking for. So the only real question left is, how are you going to use this to your advantage?